So hopefully I didn't scare you off for this question. Don't worry, we're going to slowly lead up to this question so you can see the basic. So it's not going to be a full-on, crazy stuff when it comes to it. But what we want to do now is define a couple things. So we're going to define something called an event. So an event is denoted with capital letters A, B, C, pretty much all the alphabet, when it comes to it, just along the capital. Okay. So an event is any collection of results or outcomes of a procedure. So we're going to skip this one out and we're just going straight to the main one, sample space. So sample space is denoted as capital S, and it consists of all possible simple events. That is, the sample space consists of all outcomes that cannot be broken down. Okay? So here's an example of what I mean by those two definitions above. So let's suppose we want to toss a coin, okay, and we want to find the sample space. So here's a question for you. What are the possible outcomes we can have by tossing a coin? Well, if you toss a coin, you can either get heads or tails, correct? There's no other way around it. So therefore, our sample space is heads, comma, tails. Those are the two outcomes that could possibly happen, or for short, S is equal to HT, right, for heads and tails. That's how we define our events. We literally list out all the possible outcomes that can happen according to that portion. Okay? So let's do a little bit more complicated one is what if we toss two coins now? So I toss one and toss the other one, so like simultaneously. And again, now we want to figure out what the sample space is. Well, if I toss two coins, what's one outcome I can have? Well, I can get heads, heads, right? That's one outcome. Well, I want to list all possible outcomes. So I can get heads, heads, I can get heads, tails, 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 or tails, heads. Now, you may think, well, those are the same thing. However, according to the definition, we want all possible outcomes. So even though you may think these are repeated, they're actually not. They're unique when it comes to it. That's the reason why. So we want to list even though they're opposites, and then you may think that you get the same result either way, but they're still counted two different things instead of instead of together. So it's individual portions. Okay. So this one we have a total of 4 outcomes when you toss two coins itself. Okay. Now it's something called defined in events. So let's say event A is getting a heads. So now we want to write down all the ways of getting a heads from 2 coins. So if I just go my sample space, how many ways of getting a heads? So I can get heads, heads, that's one way. Heads, tails, or tails, heads. So that's exactly how we define it. We just write them all down from our sample space. So as long as we have our sample space down, we list all the possible scenarios of our event itself, just like that. Okay. All right, so why don't you guys try one? So here's a little example here, having 3 children. So we want to find the sample space of having 3 children. Okay. So again, boy, girl, right? It's unique. So I'll start you guys off. So S is going to be, I'll start you guys with boy, boy, boy. Right, that's one way. And then go ahead and pause it and go ahead and try all the other ways possible you can think of having 3 children when it comes to it. So 3, 2, 1, pause. All right, so hopefully you guys got it. It's actually a pretty lengthy list, and it looks like that. You should have a total of 8 scenarios when it comes to it. Okay, so you get boy, 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 girl, girl, obviously, and then the combinations of each one. So like I said, even though you get 2 girls here and where's it? 2 girls there, they are counted differently. I cannot stress that enough when it comes to that. Just because you think they're the same doesn't technically mean they're the same thing, the same outcome as well. Okay, you have to write down all possible scenarios. So we have a total of 8 outcomes when it comes to having 3 children. Okay, so now using that portion, let's go to B. It says define the event A having a boy. So we're going to write down all the events of having a boy. So I can have boy, boy, boy. I can have boy, girl, boy. Boy, boy, girl. Girl, boy, boy. Not here. I can have it here. Boy, girl, girl, boy, girl. Girl, girl, boy. And then finally, boy, girl, girl. So that is how we define an event. We just write down all the scenarios when it comes to that kind of portion. Okay? So why don't you guys try the next 2? So C says define the event B having 2 girls, so only 2 girls, and then define event C having all girls. So do a quick pause. 3, 2, 1, pause. All right, so hopefully you guys tried it. So my event B is going to list out all the ways having two girls. So again, going back to my sample space, two girls. So I have two girls here. So boy, girl, girl. That's one way. I can have girl, girl, boy. That's the other way. This one here, girl, boy, girl. And I believe that's all of them, right? This is three girls. Yep, that's it. That's all the ways of having two girls. And the last one, having all girls, there should be only one, right? It's just girl, girl, girl. It's the only way to have it all girls, right? So here we have total of 1, 2, 3, 4, 5, 6, 7 different ways. Here are 3 outcomes, and here we only have 1 outcome. So here is a fun little activity for you guys. Why don't you guys try question 2? So all of question 2. So find the sample space of 4 children now. Define the event having 2 boys, and then define the event having a girl. So we're going to say 1 girl, make it easier. So having 1 girl for C. Okay. So again, just do a quick pause. 3, 2, 1, pause and try it out. Guarantee you it's more than you may think. All right, so hopefully you guys tried it out. So you guys ready for the answer? So having 4 children, the sample space looks like this. There's a total of 16 outcomes. A lot more than you guys probably have thought. Okay? Again, because the order which does matter, right? So just because you may have the same portions, they are accounted differently. So a total of 16 outcomes. Pretty crazy, huh? So it gets pretty big after a while. Okay? So now that we have that going on, now let's answer B and C down there, right? So B says, define it at having 2 boys. So we're going to write down all the ways we can have 2 boys, right? So we can have 2 boys, let's see, well, 3 boys right here. We can have boy, boy, girl, girl. That's one way. Right here, we have boy, girl, girl, boy. These are all girls. And here we go, girl, girl, boy, boy. And then girl, boy, girl. And these 2 down here, right? Because they have 2 boys there. So the opposite. So boy, girl, and then girl, boy, girl, boy. So how many outcomes total? 1, 2, 3, 4, 5, 6 outcomes of having 2 boys, and essentially, right, having 2 girls because of that as well. Okay. And the last question, define the event of having 1 girl. So we just want 1 girl, so essentially you want 3 boys, right, when it came to it. So we can have it this way. So we can have 2 boys, a girl, then a boy. We can have a boy first, a girl, then 2 boys. We can have a girl first, and then 3 boys after that. And I believe that's the only ways of just having 1 girl. So only 3 outcomes. Okay. All right, so hopefully these weren't too bad, right? You know, just all it is defining sample space when it came to it. Okay? So let's try a little easier one when it came to it. This one's a little easier. So question 3 says, you roll a 10-sided dice, so it's a dice that's 10 sides, right? Find the sample space. Well, as the sample space, what are the outcomes that can happen? Well, I can roll a 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Those are the all possible outcomes that can happen, right? Just roll in it. That's it. Just define it, right? And just list them out. Okay, B says, define the event C, roll in an even number. So looking at my sample space, so what are the numbers that are even? So 2, 4, 6, 8, and 10, right? So this is a total of 10 outcomes. And here has a total of 5 outcomes. So in other words, this event happens 5 times out of 10, right, when it comes to it. Okay. Next one, C, rolling an 8. Okay, so what are the ways of getting an 8? There's only one outcome, right? There's only one way you can get an 8. It's just one outcome. There's no multiple 8s there. And then D, rolling multiples of 3. This is a tricky one, right? So what are the multiples of 3 in our sample space? Well, there's 3, there's 6, and there's 9. So there's total 3 outcomes here. So hopefully these aren't too difficult. Again, your homework will go over roughly this portion and then slowly transition to the next part. But now that we have a little bit of grasp of how to define sample space and how to define an event, now let's go into the actual probability stuff of how do we find the actual answer stuff, right? So we're always going to be using the classical approach because it's the most common one, or equally likely events, okay? So first thing we're going to do is define a very important notation. It's called P parentheses A, okay? So it's not P times A, this is the key thing, okay? So P parentheses A means the probability of event A occurring / happening, meaning this entire sentence means that, okay? So in your questions, they can ask you that whole sentence, or they can just ask you that. What is da 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 da, or what is that? They mean the exact same thing. That's the very key important stuff. It is not multiplying, it's just a notation purposes. Okay. Now, this notation of this probability has an equation. It's right here. It is the number of ways A can occur divided by the number of different possible ways, or in other words, the sample space. So in our probability, this is always going to be the case. It's going to be the event divided by the sample space and round it to 3 decimal places. Right. One more thing before an example is a very important property of P of A, the probability. A probability is always between 0 and 1, meaning it is always a decimal. It is never less than 0 and never greater than 1. Okay, so it's always going to be a fraction. You can give it to me in decimal, fraction, or percent. And most likely, decimal and percent are the most common ones. Fractions are not very used unless they're super small. But in our case, it's going to be decimal or percent itself, okay, when it comes to it. So again, so for you math majors or math people out there, right, probability of A is always bounded between 0 and 1. It has to be a decimal itself. So if you get anything more than 1, it is automatically wrong. I don't even have to check it.